Hey, good morning, everyone. All right, so this is the video for the 6th of March HBL. Okay, so just as a recap, okay, on the naming of ionic compounds as well as the chemical formulas. Okay, before I go through the examples, and then later on I will go into covalent bonding. All right, okay. So today I'm going to do I'm targeting to do page 20 all the way to, let me see, okay, perhaps page 30. All right, okay, let's see how much I can go. Okay, I'm intending to record 1 hour 15 minutes video. All right, okay. So some general rules in naming ionic compounds. Okay, just as a recap, that day we say a compound made from two elements has a name that end with IDE. So you notice I don't write sodium chlorine, but instead I write sodium chloride. Or things like magnesium oxygen. You notice I don't write magnesium oxygen, but I write magnesium oxide, IDE. And then for negatively charged polyatomic ions, okay, I instead of it normally ends with a ATE. Okay, for example, like your carbonate CO3 2 minus. Okay, so these are something unique. Okay, polyatomic means basically there's more than one atom lah. Okay, in essence. Okay, there's carbon, there's oxygen out here. Okay, there's a couple of them that we are going to look at. For example, like nitrate. Okay, later on is inside the table, so you don't really have to copy this part down lah. I'm just writing here just to show you a couple of examples. Just hang on. Okay, just right at the next section. All right. Okay, so the positive ion, also known as cation, always comes first. Okay, the positive ion, cation, always, you name them first before the negative ions, anion comes in, right? Okay, then you also have things like, for example, calcium chloride. You see calcium always coming first, potassium always coming first, or even ammonia. Ammonia is quite a special one in the sense that it's a polyatomic positive ion. Okay, one of those rare positive polyatomic ions. Alright. Okay, so these are all the positive ions. So we always name them first. Okay. Right. Okay, so let's look at the chemical formula, okay, of all these ionic compounds. Okay, yeah, singular for formula, formulae for plural. Okay, so for ionic compounds, the chemical formulas are actually derived from the chemical formulae of its positive and negative ions. Okay, including the charges. Okay, so first of all, we need to know the formula of these ions before we can write formula for ionic compounds, right? Okay, so some of the key ones to take note is, for example, like your silver as well as your zinc. Okay, and then you have this one, which is very important. Okay, this one I put a heart shape, means very important. You need to learn by heart. Alright, okay, so ammonium is the polyatomic ion, positive ion. So this one you cannot see from periodic table one. Okay, these two you can, if you know lah. Okay, can see lah if you know. Okay, so let's go to a periodic table. Okay, so that day I already indicated for this one in the middle block, group 11 and 12. Okay, you have silver, there's 1 plus, as well as zinc, there is 2 plus. Okay, yeah. Okay, so silver is in group 11, and then zinc is in group 12. Okay, very unique. They are not in group 1 and 2, but it's always 1 plus and 2 plus respectively. So do take note of these fellas, right? Okay, going back to the notes. On top of that, you have ammonium, which you got to memorize. Okay, then you also have, let me see. Okay, all these you realize there's a bracket II, all these are actually the charges, okay, of the transition metals, okay. So if it's II, it means it's 2 plus, you can see, II 2 plus, II is 3 plus, okay. Right. Then the rest you actually determine from the group number itself lah. Okay, that one I think quite straightforward. You don't really have to memorize. Just know from the periodic table that group one is 1 plus, group two is 2 plus. Then aluminium in group 13 is 3 plus. Hydrogen, this one quite unique is 1 plus Okay, you might want to take note lah. Then there's another thing called H minus also. This is called the hydride. Okay, so we have the H plus, we just call them the hydrogen ions that you find in acids, right? Okay, can. Okay, let me go to here. Okay, yeah. So you might want to add on in this list or inside your periodic table. There's hydrogen, which is H plus. Yeah, you might want to add on in this list itself. Okay, so don't just view the segment with the notes. Do take note of your periodic table part as well and make in the relevant annotations inside your periodic table. Right? Okay, so back to here. Alright, okay, then we also have the negative ions. Negative ions, basically, there's a number of them okay. There's 5 of them okay, 5 polyatomic ions that you need to memorize. Okay, so just to maybe take one example, which is your carbonate. Let's say is carbonate, so starts with a C okay. So the charge is at the top okay. Then this one means the 3 at the bottom is not the charge it means there's 3 oxygen atom alright, in these polyatomic ions, okay. Or for example, like nitrate, the one, okay, NO3 minus, sorry, okay. So yeah, the charge is 1 minus the charge, okay. And then this thing, basically there's 3 oxygen and 1 nitrogen, right. Same goes for the one that is S sulfate SO4 2 minus, okay, that's your sulfate. So that one you got 4 oxygen, and then 2 minus is actually the charge, right. Okay, right, okay, a lot of them okay. I shall go on. Okay, so now I'm talking about the rules for writing your ionic right. Okay, so now there's some rules on writing the ionic formula. Okay, maybe I go through the examples for the naming one first so that it won't be too many things for you at one shot. Okay, right, correct, cool. Okay, so example 15 is for the naming the chemical name. Alright, okay, so let's go through this part first before I go through the formulas with you. Okay, if not, I think too much information download at one shot Okay, I shall do 15 first. Okay, so now you have this one AgCl. If you check your periodic table for what is Ag and what is Cl okay, so this one you go and see the periodic table. Okay, for the name some of them AgCl. Let's go and see. Okay, go to the periodic table. Ag is here, silver. Cl is this. Okay. In group 17, chlorine. Okay. Then we go back. Okay, this is actually silver chlorine. Okay, but do you do this? You actually don't, right? Okay, you will change it to IDE. Alright. Okay, silver chloride. Okay, this one actually belongs to the rule number 1, right? Okay, over here. Okay, silver chloride. Okay, let's look on. Okay, next one. You have your CuCO3. Okay, so Cu is actually if you figure it out, okay, CO3 is a polyatomic one. Remember, this is the carbonate. Okay, that one is under where? Here, carbonate. Okay, then Cu is this one, copper 2. Okay, so transition metal okay, copper is actually here. If we look at the periodic table, okay, over here, copper, right? Okay, so you can change it. Okay, it's actually 2 plus the charge. Let me see. Okay, so because this one CO3 is 2 minus, so the copper to balance off the charge is 2 plus. So we call this copper II carbonate. Okay, I will normally put this for transition metals. Okay, this is for transition metals. Okay, to tell people the charge. Okay, transition metals, what are they? They are actually from group, let me see, group 3 to 11 generally. Group 3 to 11 generally. Okay, group 3 to 11 generally, transition metal. Okay, you put this bracket. Okay, next one, I have MgO. This one is straightforward. Once again, just see from periodic table. Mg is here, O is here. Alright, okay, magnesium oxide. Okay, so we don't call this magnesium oxygen. You don't do that. You actually call it magnesium oxide. Yeah, right. Okay, then next thing I have ALP. Okay, Al with the small L down here. Right. Okay, so Al is down here, and P is down here. Phosphide, aluminium phosphide. Okay, so this I have aluminium phosphide. Okay, no need to write the II, all those Roman numerals, because they are not transition metal. Okay. Okay, next one I have, okay, NH4 plus. You see this bracket, later on I tell you why. NH4 plus and then SO4 2 minus. Okay, ammonium sulfate. Alright. Okay, so you have the sulfate here as well as the ammonium here. Okay, so this thing, you name the cation first. You call them ammonium sulfate. Okay, right, then the next thing. Okay, so sodium hydroxide. Alright, okay, so this one you have Na sodium, that's from this particular group 1. Okay, over here. Okay, I hope you start familiarizing yourself with the different elements already in your periodic table. Okay, then this one is sodium. Okay, OH is this one. OH minus, the polyatomic one. Okay, just let me refer back. Okay, so constantly refer back to this part in the notes as well as your periodic table to do this part. Okay, sodium hydroxide. Okay. Oh, yeah, I think there's a repeat of 2 ammonium sulfate. So maybe just let me give you an easy one. Okay, so this one maybe you go with Na2 S. Okay, do I have no, got repeat also. Okay, never mind. Give you CaCl2. Okay, CaCl2. So this part, if you refer to your periodic table, is your calcium, and then Cl is over here, calcium chloride. Okay, so this one you have calcium chloride. Right, okay, then let's go on. Okay, I also have AgNO3. Okay, so this one is your if you look at it, Ag is actually silver. This one is your, where is it? Okay, now here, silver. Okay, and then we have NO3. NO3 is in the notes. Okay, nitrate. So silver nitrate for this part. Okay, then let's go to PBI2. So PBI2 you have this one is lab 2 over here. Lab 2. I'll tell you why it's lab 2, okay, in a short while, because that one you need to work out the charges. So this one is your lab 2, okay, because it's PB2 plus. PB2 plus, then I is I minus. So this one we have lab 2 iodide. Okay, so this one you can check from your periodic table actually. Lead is down here, then iodide is down here. Lead 2 iodide. Term checkpoint. Okay, then next thing I have sodium carbonate. Okay, so this one is this way. Sodium carbonate. Right, so for this one, you have this one. Okay, Na, sodium over here, and then you have carbonate. Right, okay, right, okay, going back. Okay, I have this carbonate. So sodium carbonate for this one. Okay, next thing, same thing. Okay, I have calcium carbonate. Calcium, you can look up the periodic table right. Then next thing I have KOH. So this one is split into K plus and OH minus. So K plus is from the periodic table. Okay, and then OH minus is from here. Hydroxide. Okay, so this one is your potassium hydroxide. Okay, so next part I have Ca again, so calcium, and then PO4 is the polyatomic ion, PO4 3 minus, the one with charge 3 minus, and then you have PO4. Okay, so calcium phosphate. Okay, and then I have okay, so you have barium nitrate for the next one. Okay, so barium is from nitrate is down here. Okay, this one. Then you also have from the periodic table barium. Barium is over here, also in group 2. Right, okay, so back here I have barium nitrate. Okay, Then okay, the other one is you have this one is your Fe3 plus O2 minus. Okay, so later on I'll tell you why is it Fe3 plus and O2 minus right. Okay, so this one you have iron, III, oxide okay, so this one is transition metal this fella, iron okay, transition metal. Okay, from wait let me see a group okay, group 8 for this one. Alright, okay, this one is from group 8 so this is from group 8. Okay, then next one I have Na and S. This one if you see from the periodic table, sodium sulfide this one, not sodium sulfur okay, please don't write this as sodium sulfur it's wrong so change to IDE, sodium sulfide. Yeah. Okay, and the next thing is on the formula. Okay, let's go through the rules first okay, so when you write chemical formulas, okay, what you have to do is this okay, write the symbol of the positive ion first, just like when you write the name. For example, sodium chloride, you don't write Cl and Na. Alright, and then the number of atoms is written as a subscript, okay, to the right of the atom's symbol. Okay, for example, like this one down here, okay, you have MgCl2, okay, means you have one magnesium, okay, and then two chloride ions okay, this one is all ions. Okay, likewise for this one, okay, one calcium ions, okay, and then you have one carbonate ion. Okay, this one is one carbon and three oxygen but inside the carbonate itself, okay, you have one carbon and three oxygen, right? Okay, that's for understanding purposes okay, so the next thing, okay, the subscripts are the simplest set of the whole numbers okay, for example, later on, because I will introduce you to this crisscross method right. Okay, there's two methods to write these out of things one is to balance the charges, the other one is the crisscross method. Okay, so this one, okay, is Ca2 plus O2 minus okay, please don't write this as Ca2O2 don't do that okay. Alright, okay, so if same charge, you just write down as 1 to 1 okay, so later on I'll guide you using the steps. Okay, then do not write subscript 1 if it's 1. Okay, so never ever do such thing as Zn1O1. Okay, then if there's more than one polyatomic ion, okay, the ions will be placed in brackets you take note of all this, because later on we are going to do this crisscross method for example, easy one is something like this. Okay, magnesium chloride. Okay, magnesium, if you check from the periodic table okay, is under group 2 2 plus. Chloride is under group 17, 1 minus. Okay, so going back to this, okay, you have Mg2 plus Cl minus, so this one gives you MgCl2 okay, so you do a crisscross 2 comes here, 1 comes here. Okay, so this one, Okay, then you also have cases whereby you have like for example magnesium nitrate where it's not monoatomic ions. Okay, so this one you have Mg2 plus NO3 minus so this one you when you do a crisscross, right, because it's different charge you don't put just two like that. Okay, you got to bracket out the two, so this one gives you MgNO3 bracket 2. Right, okay, so I'm going to introduce, there's two methods but basically they work on the idea that the number of electrons gained, which is a negative charge, has to be equals to the number of electrons lost, which is the positive charge. Right, okay, like for example Al3 plus and F minus. Okay, you have got to have three of these to balance off the Al3 plus, or like sodium oxide, you got to have two of the Na plus to balance off the O2 minus. Okay, then you got to have three of the OH minus to balance off the Al3 plus and then you have two of the ammonium, okay, to balance off the SO4, but of course put a bracket because it's polyatomic ions. Okay, right, okay, let's look at the crisscross method okay, for the start I'm going to use this method more the crisscross method. Okay, so this one you have Ca2 plus OH minus so this one you got to do crisscross CaOH2 okay, so different charge, remember, then you do crisscross so your 2 comes here, the 1 comes here, so you do a bracket OH2. Okay, then the next thing, if you have the same charge, okay, like for example Ca2 plus calcium oxide O2 minus, then you write down into 1:1 same charge 1:1. Okay, so this one you have CaO okay, then also you might have sodium chloride, for example, I have Na plus Cl minus okay, then this one also NaCl, this one same charge so you don't care is whether 2 plus 2 minus 1 plus 1 minus, so long as it's same charge you do 1:1. Yeah, then if it's different charge, okay, then you need to put a bracket, okay, because this one is polyatomic if it's different charge but okay, if it's different charge polyatomic this case but another case is this. Okay, for example you have magnesium chloride for example then this one is not polyatomic, this one is Mg2 plus Cl minus. Okay, if you refer to a periodic table once again okay, Mg2 plus and then this is Cl minus. Okay, right, okay, okay, so then this one you no need to put down, okay, you just put as MgCl2 carry. Okay, because it's this thing is monoatomic. Okay, then you okay, let's go to the examples okay, of writing the chemical formula. There's a couple of them. Okay, let's try to look at them. Okay, so you have sodium bromide so this one is your Na plus then Br minus. Okay, sodium bromide. Okay, so plus 1 minus 1, so this case is your same charge okay, then just write down 1:1 okay, and it's all monoatomic, that's the thing. Okay, so this is sodium sorry, this is NaBr, right? Okay, let's look at B. Okay, this page example is still quite okay one, okay, because it's all the monoatomic, no brackets one okay, this page I think is all the monoatomic one. Okay, so this one is your Ki. Okay, so same thing, same charge, so you write down in A 1:1 ratio. Okay, next thing you have your magnesium chloride. Okay, this one is your Mg2 plus Cl minus. Okay, I can write it very fast because I've been writing for very long. For you, you probably need to check your periodic table. Mg2 plus and then Cl minus. Okay, so MgCl2. Okay, next thing you have calcium fluoride. Where is calcium? If you check your periodic table, okay, it's calcium, and then fluoride, is it? Next thing, fluoride. Okay, fluoride is in group 17 also, right? Okay, so let's do this. Ca2 plus F minus. So this case, you like just like earlier on, you have different charge. So you actually do your crisscross method over here. Yeah, so CaF2. Alright, so you do your crisscross method over here. Okay, next thing you have your cesium sulfide. Okay, cesium sulfide. Let's take a look at cesium sulfide. Okay, cesium is in group 1. Sulfur is in group 16, so 2 minus. Okay, let's take a look. Okay, so cesium Cs2 plus not 2 plus, 1 plus, group 1. What am I talking? Okay, so this case you need to do a crisscross. Cs2s. Okay, so the 2 comes here, the 1 comes here. Okay, so this case is different charge. So you do the crisscross. Okay, next thing I have calcium phosphide. Okay, the same calcium as just now. Okay, calcium is here. Phosphorus is here. Okay, phosphide is the anion of phosphorus. Okay, group 15, so it's 3 minus. Okay, so this one is Ca2 plus P3 minus. Okay, so copy down the symbol first. That's always the first thing. Then you put a 3 here, you put a 2 here, right? Okay, 3 comes here, 2 comes here. So shift the numbers without the plus and the minus. Right? Okay, so next thing we have the sodium oxide. Okay, so sodium is the Na plus from group 1. Oxide is O2 minus. Sodium, then O2 minus. Okay, so this one you have Na2O. Okay, next thing we have the potassium sulfide. Okay, so this one you have K plus and then S2 minus. Okay, right, then I have potassium sulfide. So this one is K2S. Okay, so I just give you a few moments. Okay, you go on to try. Okay, there are a few special ones. Okay, so do take some time. Okay, I'm gonna give you some time okay, to try this out before I go through everything. Okay, so you have the copper 2 hydroxide. So that is Cu2 plus OH minus. Okay, so this is a case you have different charge and polyatomic. So you do CuOH2. Okay, but remember to put the bracket around the polyatomic ions. Okay, so this one is different charge. So what you do is you will do a crisscross and then have a bracket. Okay, on the polyatomic ion. Okay, on polyatomic ion. Okay, Then you also have transition metal one, like copper 2 oxide. This is Cu2 plus. Okay, this one tells you the charge. This I tells you about the charge. Okay, then oxide is O2 minus. Okay, you can see from the periodic table oxide is here. Yeah, group 16. Okay, so this one will be 1:1 because same charge. Okay, then what else I want to highlight to you okay, so sometimes you got this thing called acid are very important. Okay, because we have a big chapter called acids and bases. You got to know the formulas of acid very well. Okay, so let's say you have sulfuric acid. Okay, acid is H plus, the cation. Every time you see acid, this word okay, is H plus. Okay, then sulfate is the polyatomic ion. Okay, sulfur. So this one you can go back to your notes to take a look. Under this segment where I say you need to memorize so maybe you want to put heart shape, star shape, whatever you want to put. Okay, so so this one you copy down H and SO4 first then the 2 comes here, the 1 comes here. Alright, okay, so you try these few examples out first. I give you a few moments. Okay, you can pause the video and try these examples before I go through. Alright, okay, back to this okay, so I have I see quite a couple of example. So I have barium oxide. Okay, so this is Ba2 plus O2 minus. Okay, so barium is in group 2 Okay, oxide is in group 16. Okay, so this one same charge, so you write down as BaO. Okay, so this one is the same charge. Okay, then next thing you have aluminium oxide, so Al3 plus and O2 minus. Okay, so this one very clearly okay, it's a case of different charge. Okay, so just now same charge you write 1 to 1, different charge now you write you do a crisscross. Okay, so what do I mean by crisscross? You write down your Al, you write down your O. Okay, so the 2 comes here, the 3 comes here. Okay, so normally I'll copy down the symbol first, then do the numbers. Yeah. Okay, so this one is iron 2. So this shows you the charge. Is Fe, this is O. So this is 2 plus, this is 2 minus. So FeO, okay, same charge, you write down 1:1. Okay, only special thing to really take note in this case is a transition metal, so the charge is actually shown inside this II. Okay, next thing I have calcium hydroxide. Okay, calcium is in group 2. Okay, once again, we look at it a couple of times actually today. Okay, so you have Ca2 plus, then you have oxide, which is OH minus. Okay, oxide is polyatomic ions. You look up this, correct, this one. Okay, so I have calcium oxide, so CaOH2. Okay, but something is wrong. Okay, different charge. You crisscross, but there's one additional thing you do is to bracket up the polyatomic ions. Alright, okay, pretty much like O like that. Okay, then I also have zinc hydroxide. Okay, zinc, if you see, is a very unique one over here. Okay, it's 2 plus always, but it's not in group 2, right? Okay, so over here. Okay, so this one is Zn2 plus OH minus, so Zn bracket OH2. Okay, different charge in this case, so you have to do crisscross. And then bracket the polyatomic ion. If you need more than one of the polyatomic ions, you need to bracket the polyatomic ions. Okay, when there's more than one. Yeah. Okay, so next one is iron 3 hydroxide. Okay, what is that? Okay, this one is your Fe3 plus. Okay, based on this, then hydroxide is the same as previously. Okay, so this one FeOH. Okay, I copy down first. Then the 3 comes here, but remember, it's more than one of them, so I need to put bracket because otherwise the meaning is different. Okay, alright, in OH, okay, if I write as like 2 ways, okay, you see, without the bracket and with the bracket, okay, without a bracket is this way, with the bracket is this way. Okay, in terms of the meaning, what is different is that this one you have 1 iron, 1 oxygen, 3 hydrogen, but this one you have 1 iron, 3 oxygen, 3 hydrogen. Okay, basically this thing doesn't exist one. FeOH3 without the bracket. Okay, alright, okay, let's look at the next one, silver nitrate. Okay, silver is that fella that is down here, Ag. Okay, today I think we also seen it a couple of times. Okay, so nitrate is one of the polyatomic ions. Okay, so you'll probably be like me searching around for the start, okay, until you get more familiar with these fellas. Okay, so now I'm just showing you what you should be doing at the start. Okay, but as you get better, okay, hopefully you will memorize, start memorizing those polyatomic ions. So you need some memory work down here. AgNO3, okay, because this fella is the same charge. Okay, Then moving on, I have barium nitrate. Okay, barium, I think we also seen it quite a number of times under group 2 for today. Okay, so this one you have Ba2 plus NO3 minus. Okay, so this will be Ba bracket NO3 2. Okay, but normally what I do is this first. Okay, maybe I should explain first. Okay, is that it has different charge. So I need to do crisscross. But what I do is this, I will write a Ba, then a NO3, then I put 2 down here, then followed by the brackets. Yeah. Okay, then next thing I have the copper 2 carbonate. So this is a Cu2 plus, CO3 2 minus. Okay, copper 2 transition metal. Carbonate polyatomic. Okay, if you write C over here. Okay, so this one is you write down 1:1. Right. Okay, then the next thing I have iron 2 sulfate. So this is Fe2 plus, SO4 2 minus. So this one you have FeSO4. Okay, then you also have sodium sulfate, Na plus, SO4 2 minus. So this one is Na2SO4. Okay, so this one is the same charge case. This one is the different charge case. Right. Okay, then we have ammonium sulfate. Okay, this is ammonium is the polyatomic ion down here. Yeah, over here. Okay, the thing is very often it's confused with another term okay, called ammonia. Yeah, ammonia means NH3. Is ammonium NH4 plus. Alright. Okay, NH4 plus, SO4 2 minus. Okay. Then I also have 9. So this one is a different charge. I got to do a crisscross over here. Okay, NH4 2, SO4. Yeah, with the bracket lah. Okay, so this involves 2 polyatomic ion. Okay. So this one is a polyatomic ion, this one is a molecule. So I was saying people very often confuse between ammonia and ammonium. Although the spelling is very similar, but actually they are actually quite different in a sense. Okay, in terms of the chemical meaning behind it. Okay, then we also have nitric acid. Okay, that is H plus, NO3 minus. So this case is a 1:1 same charge, HNO3. Then I have sodium carbonate. Okay, Na plus, CO3 2 minus. Okay, so this will be Na2CO3. Right. Okay, so different charge. Okay, and lastly I have ammonium carbonate, NH4 plus. Carbonate is another of those polyatomic ions. So this one I need to do a crisscross, NH4 2 bracket then CO3. Yeah. Okay, so I have ammonium carbonate. Yeah. Alright. So any questions, do post them on Teams for me. Alright. Okay. And next thing, okay, let me see how much I can cover. Okay, for your covalent bonding. Okay, so I think there's quite a couple of them. Okay, so covalent bonding okay, is unlike ionic bonding. Okay, so when you come back from your March holiday, perhaps I will show you some models. So covalent bonding is defined as the chemical bond formed by the sharing of electrons, okay, between 2 non-metal atoms. Okay, and then covalent bonds can be formed between atoms of the same element or otherwise different elements. Okay, so usually down here this part we are dealing with molecules. Okay, remember the definition of molecules is two or more non-metal atoms chemically combined. Okay, so they can be from the same element or molecules of compounds. That means from different elements. Okay, so two or more non-metal atoms chemically combined together, right? Right. Okay. Then it's also helpful when we look at the group and know the number of bonds that it forms. Okay. So because we will know based on the group how many electrons it will share. Okay. So this part is about the sharing of electrons. Okay. So how many to share is basically the group will tell you. For example, like group 1, 2 and 13, actually they are metals, so they won't be involved. Okay, remember we are looking at non-metals. Okay, so metals won't be involved. That's why as well as noble gases. Okay, so for group 14 is 4 electrons, group 15 3 electrons, group 16 2, group 17 1. Okay, and then the single bonds. Okay, so single bonds are formed when two atoms each contribute 1 electron, okay, to the bond, okay, resulting in a total of 2 electrons being shared. Okay, this case, for example, how do I know they share one? Okay, let's look at the electronic configuration. If it's 7, right, okay, then usually they will share 1. Okay, because the number of electron it needs to get okay, will be equals to the number of electrons it shares. Okay, so need how many, share how many, right? So basically this is what happens. Okay, so then you put in a legend, don't forget. Okay, dot is electrons of first fluorine, cross is electrons of second fluorine. Okay, this one must be done. If you've never done, usually I'll penalize 1 mark. It's usually a 2 marks question. Okay, so yeah. Okay, so this one is the full electronic configuration. Sometimes the question just like ionic, they only ask you to draw the outermost. Then you outermost electron only. Then what you do is you just show the outermost. Like in this case, what I'm doing is the outermost. 1 dot 1 cross dot 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 cross cross cross. Okay, then you also form double bonds are formed, okay, when two atoms each contributes 1 electrons, okay, to the bond. Sorry, 2 electrons I mean. Okay, for example like your oxygen. Okay, so oxygen is 2 6 over here. You will share 2, left 4. Okay, so this one you got to see how many you share and how many you are left with. Just now fluorine will share 1, left 6. Okay, that's why you see 6. 1 2 3 4 5 6. Okay, share 2, left 4. Okay, so a total of 4 electrons, okay, are being shared. Okay, share 2 left 4, sorry, share 2 then left 4, not 4 being shared. Okay, so then you have triple bonds, okay, like for example nitrogen is 2 5. This one is a bit cluttered lah. Okay, later on we'll draw this one, don't worry. Okay, so this one you'll share 3 left 2 okay. So this one 3 electrons, okay, and then a total of 6 electrons being shared. Okay, hydrogen more straightforward. Hydrogen is just 1, so you share 1 left nothing. Okay, so you see the main thing that I'm trying to do down here is figure out how many you will share, how many is left with. Okay, as for carbon is 2 4. Okay, over here so you share 4 left 0 also basically. Yeah, then same goes for the hydrogen it's 1, so share 1 left 0. So actually I don't care about the inner electrons. Actually I don't really care in my consideration. Yeah, although sometimes I need to draw it there if they want the full thing. It's more about the outer electrons. Okay, so then there's also this thing called the structure formula. So you notice I write 1 single bond, 2 bond, 3 bond, 4 bonds. Okay, 4 single bonds. So how do I do that? Is I put 1 line. Okay, one line down here is equals to 1 bond, which is equals to 1 shared pair of electron. Pair means 2. Yeah, so for example oxygen one will be like that. Nitrogen one will be NN triple bond. This one will look something like this. Okay, so this one is what we call the structural formula, which I'll guide you through as well with the examples. Okay, so this one is a structural formula. Okay, so next thing, okay, method 1 to draw okay, although I prefer method 2 for the start okay, more complicated ones you need to use method 1. Okay, so I introduce you both methods. So method 1, from the group number you have to determine the number of covalent bonds. Okay, each atom will form. Okay, then construct the structural formula. Okay, so for example H you can see like that. Okay, then you ask yourself, okay, it's very clear once you know that it forms 1 bond, then how many is left with from here. Okay, so like oxygen, you know you will form 2 bonds. Okay, so that means from here you know that it shares 2, then it has to be left with 4. Yeah, okay, so every bond is a shared pair of electrons okay, nitrogen also like you know from here, okay, you know share 3, right, because there's 3 bonds, then left 2. Okay, but for the start, okay, I'm going to use this okay, method 2. Okay, it's very guided I would say. Use the circles to represent the electron shells, write symbols, then use the part where circles overlap to show the number of shared electrons. So the number of electrons required equals to the number of electrons that will be contributed for sharing. Then write your legend. Draw the shared electron inside the overlapping part. Then after sharing, count the number of valence electrons. Then top up the remaining electrons outside the overlapping part of the valence shell. And then double check that both atoms have the full valence shell. Okay, so for the start, I'm going to guide you using some thinking process first. Okay, before we go into further examples. Okay. Let me see, do we have a lot to draw? Okay, let's take a look using the chlorine example first. Okay, let's take a look. Okay, so chlorine. Okay, so let's look at chlorine. Okay, we have a case of 287. So the very first thing I'll do is write down the electronic configuration. Okay, based on the proton number. Okay, you go and see chlorine is 17. So 17 electrons to play around with. Okay. So for the purpose of this exercise, just going to focus on the outermost, or what we call the valence electrons. Yeah. Okay, so the number of electrons each chlorine share based on this one is what? Share 1. Then 7 minus 1, you're left with 6. Right? Okay, so I have 2 chlorine, Cl2. Okay, so I'm just going to draw the outermost. Okay, make sure you draw a nice circle with enough space down here to put the shared electrons. Okay, then left 6, I'm going to reflect the 6 outside. Okay, the 6 crosses for this chlorine, right? Okay, then I have the legend. Okay, so this case is quite straightforward. It's for the it's the same elements. They are molecules of the same elements. So this one is electrons of a Cl. Cross is electrons of the second Cl. Okay, so structural formula. Share one pair of electrons gives a single covalent bond. Okay, so you only share one pair, so the structure formula you only have one line. Okay, so do have use this checklist whether you put in a symbol, correct number of shared electron, yes, right, because it's one. Legends included, yes. Then check the right number of valence electrons. Okay. Check the question asked for outermost shell or full. Okay, in this case I'm just drawing the outermost alright. Okay, can. Okay, then okay, so those that are from the same element will be something like fluorine and oxygen okay, you can try them out. Okay, so fluorine is 2,7, so same thing okay, this case you share 1, left 6 okay. So if this one you need to show all okay, this one you need to show all for this question. Okay, so you write a F. Okay, wait need a bit more space because you need to show all. Okay, this way. Then I do a bigger one for the outermost shell. Okay, so fluorine, then one down here. Okay, so do remember not to put one additional circle okay, circle means shell in this case. Don't anyhow put one additional circle so be very careful with the number of circles you draw inside Some of you got this habit to just randomly draw one circle. Okay, don't do that okay, I will penalize you in your exam Okay, so then legends electrons of the first F, cross is electrons of the second F. So FF single bond. Okay, then you have oxygen is 2,6. So this one you share 2, left 4. Okay, so wait, let me fit this in so oxygen share 2, this is the inner 2. Okay, so I do it this way Okay, so when I share 2, I'll cross dot cross dot. Okay, do it in an alternating fashion lah. Okay, the remaining 4 I put at the 12 and 6 o'clock position. 12 and 6 o'clock. Okay, then you check whether got 8 around or not. Okay, so 1 2 3 4 5 6 7 8. Okay, you don't have to write the 1 2 3 4 5 6 7 8 okay, I'm just checking only. Okay, down here. Okay, so let me erase in case it confuse you. Okay, alright. Okay, then there's sharing of 2 electrons, so O double bond. Okay, then once again, slot in the legend. Second O. Okay, then okay, so then now we look at molecules of the same element. Okay, the next part we're going to look at molecules of different elements. Okay, different elements, compounds. Okay, let's look at water as an example. Okay, for example, electronic configuration of water is 1. Okay, so number of electrons it shares is 1. Okay, then of course this one is left 0. Okay, you have 1, you share 1, left 0. Oxygen is 2 6. Okay, so this one you will share 2, so 6 minus 2 you get 4. Okay, so number of electrons is left with after sharing 2 electrons. Okay, sorry. Okay, so you will share with, okay, this line I'm asking about the number of electrons it shares with each hydrogen. So 2 divided by 2, you share 1. Okay, so it's fair lah. You share 1 each. Then number of electrons is share is left with after sharing 2. So 6 minus 2, you're left with 4. Okay, so the one that share most one, okay, will be in the middle. Yeah, so oxygen will be in the middle. Yeah, I'm just showing the outermost in this case. Okay, so hydrogen share 1. Oxygen share 2, but fair. Share 1 on the left, 1 on the right. Okay, then in the middle, at the 12 and 6 o'clock position of oxygen, I will put in the remaining 4 that's not shared. Okay, so this case you should share 1 pair of electrons to form a single covalent bond. Structural formula will look like this. There's one line on the either side of oxygen. Okay, the left and right side. Okay, then next thing is your ammonia. Okay, the first example is coming out as ammonia. Okay, let's do some planning before we start drawing. Ammonia is 2 5. Okay, so what it does is that you will share 3 electrons because you need 3 more to go to 8. Okay, share 3 electrons, then you are left with 2, right? Okay, share 3, left 2. Okay, so then you also have hydrogen. Okay, very useful if I give you a formula. Okay, might as well I just write you the formula first. Okay, so hydrogen will share 1. You're left with 0. Okay, so 1 nitrogen, 3 hydrogen. So how it looks like that. Okay, wow, this one I have to show all. Wait. Yeah, bigger circle. Okay, so I share with 3 hydrogen. Sorry, should be this way. Let me edit a bit. Okay, 2 crosses this way. Right, okay. So the legend. So once again you track by counting okay, there's like 1, 2, 3, 4, 5, 6, 7, 8. Okay, electrons around it. Okay, so the legend, this is electrons of of N. Then dot is electrons of H. Right, okay. You can try this on your carbon dioxide as well. Okay. And we have a couple of examples that we are going to look at. Okay, some quite interesting ones. Okay, then let's look at the next one. Okay, you have carbon is 2, 4. So this one will share 4, left 0. Okay, then you also have oxygen. Okay, you will share 2, left 4. Okay, so carbon will be in the middle, surrounded by 2 oxygen. Okay, so right, okay. So share 4, left 0. So be fair, so share 2 each. Okay, oxygen will share 2, left with 4. Share 2, left with 4. Okay, then we also have others here. Oxygen here. Okay, then I have the legend. Electrons of O dot is electrons of C. Okay, so this is the dot and cross diagram. Okay, so do try out these examples okay, over here. Okay, like for example, phosphorus trichloride, carbon disulfide, methane, all this. Okay, so right, okay, so all this only require you to draw the outermost so we can take a look at this phosphorus trichloride. So phosphorus is 285 okay, so 5 so this one will share 3, left 2. Okay, chlorine, I need some additional space. Okay, maybe I zoom out a bit okay, chlorine I have 287. So this one you share 1, left 6. Yeah, share 1, left 6. So phosphorus, chlorine okay, phosphorus, so share 3 left 2. And chlorine down here, okay, Then just remember to put in the legend at the very end. Cross is electrons of Cl. Okay. Okay, then you also have things like you also have things like carbon disulfide. Okay, so this one is 2,4. Okay, so this one you have 2,8,6. So this one you will share 4, left 0. Okay, this one you will share 2, and then left with 4. Yeah, right. Okay. Okay, just give me a moment. Okay, so for this you have carbon in the middle, then sulfur at the side. Yeah. Okay, so you have over here. Okay, and then sulfur sharing 2, and then you are left with 4. Yeah, so do check all of them got 8. Okay, so the legend, this is electrons of S, then dot is electrons of C. Yeah, right. Okay, then I have methane. This is 2,4, hydrogen is 1. So this one you share 4, you are left with 0. This one you share 1, left with 0. Okay, so methane, carbon will be in the middle. Oh, just now, sorry, I forget to put in the structure formula. This one is C double bond O, because share 2 electrons. This one is structure formula is this way. Yeah, N single bond H. Okay, so this one carbon in the middle. So usually the one that share the most will be in the middle. Okay, then H this way. So dot, 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 cross, 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 cross. Okay, then your legend. Okay, a bit squeezy. And it's electrons of H, cross is electrons of C. Okay, then I also have the more weird ones like diazine, sodium, hydrogen peroxide. All these would be better if you can use the structure formula to start drawing. Okay, this one let me show you. Diazine, okay, for example, like nitrogen, nitrogen, hydrogen, hydrogen. Okay, so it can form 3 bonds. That means share 3 electrons. So this is how they are arranged. So from there, I try to construct my dot and cross diagram. Okay, this way. Okay, so this one is the tougher ones. Okay, so what I will do is this okay, nitrogen, nitrogen, okay, right, okay, so the same elements I use the same symbol lah. Okay, so your nitrogen we know is 2 5, so after you share 3 you're actually left with 2 so the remaining 2 you actually put outside. Okay, hydrogen should not be left with any lah. You share 1, then you left nothing. Okay, then the legend goes this way. This is electrons of N, cross is electrons of H. Okay, so right, okay, let me finish up the remaining 2 before I stop here today. Okay, I think I'll stop at example 6, hydrogen side. So hydrogen peroxide, oxygen share 2 electrons, so normally it will form 2 bonds. Okay, so once again I'm adopting the method of drawing structure formula first. So sometimes it's better to draw structure formula, especially when it's not clear how to see the center of the atom. So oxygen here, and then you have hydrogen. Okay, so this one you have dot, 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 dot. Okay, so oxygen is 2 6, so you share 2, left 4. Okay, yeah, so the remaining 4 put outside. Okay, then hydrogen I will use cross. Yeah, so should still have 8 lah. Okay, so the legend is this way dot is electrons of O, cross is electrons of H. Okay, then your hydrogen cyanide, okay, is this way okay, C triple bond N quite unique This one your carbon, because there's 3 different elements. Okay, okay, so this one is this way right, okay, so carbon, let's take a look is 2 4, so share 4, left nothing. Nitrogen is 2 5, share 3, left 2. Okay, hydrogen of course share 1 left nothing 0 okay, so I'll use cross for this one. Open sub. Okay, I need a bigger space. Then put the remaining two outside here. Okay, so for the legend, cross is electrons of H, dot is electrons of C, and open circle is electrons of N. Yeah. Okay, so for today's video, I will stop here.